Hello, good afternoon. My name is Juan Lage. I am a principal engineer on the EMEA business unit at Cisco. This is the business unit within Cisco that is responsible for the Cisco ACI portfolio. Happy to be here at VMworld today and see some familiar faces that I haven't seen in quite some time. And I'm going to be talking to you about Cisco ACI microsegmentation. What I'm going to be doing is essentially three things. First, I'm going to do a very fast overview in 5 minutes explaining the ACI networking model. I think that is very important to understand the rest of the presentation and the topic in general. Then I'm going to try to demonstrate ACI microsegmentation capabilities, and also along the time we will be showcasing how you can configure networking and ACI microsegmentation directly from vCenter using the vCenter plugin that we provide with ACI, so that vSphere administrators can use a tool that is familiar to them. Now, before we do that, and to clarify wording, what do we mean by microsegmentation before we even start talking about ACI? Well, traditionally we have done segmentation so that you use broadcast domains to provide layer 3 boundaries between applications or tiers of applications that shouldn't be talking to one another, so that you could be providing filtering at a router device, be it a firewall or a router, so access control list or firewall rules. Now, inside those segments, there used to be very little security, so you could have easy lateral movement if you were able to penetrate and compromise any of the workloads inside a segment. Now, with microsegmentation, we're essentially meaning that you can create much more granular policies by actually creating smaller segments, or if you want, creating segments within a segment. Effectively, the idea is that you can define policy between groups of endpoints regardless of whether they are in one subnet or another, so that you can actually continue using the previous models as well as flat models from an IP addressing perspective. So that's really what we mean by microsegmentation in this context. Now, this helps greatly. Why we want to use it? Because perimeter security is fantastic and you want to keep investing on it, but it's probably not enough. Again, once you have a host compromise, you want to make sure that you minimize lateral movement protect possibilities inside the data center. And if you do that, you're essentially increasing your security posture dramatically, potentially, right? Now let's switch into ACI. And before we talk about ACI microsegmentation, I think it's very important to understand the ACI networking model. And I'm going to try to do that as fast as I can. First, ACI is a solution that is all-encompassing SDN aspects. It means it attempts to provide network virtualization, but much more. It attempts to provide really a solution for managing an entire fabric, providing network services as a single entity. So it's made out of essentially three components. A fabric, leaf and spine, high performance, low latency, Nexus 9000 based fabric. An AP controller that will provide an overarching look about that fabric and manage every single aspect in an abstract way. And a policy model that provides this abstraction. This policy model has been contributed to numerous open source projects. It's available on the group-based policy model of OpenStack, has also been contributed to Open Daylight. Now, with that in mind, let's look at ACI Networking 101. So you'll have a fabric, it's a physical fabric that will have connection to any type of external routers, be it Cisco or otherwise. That fabric will be entirely managed by the AP controller cluster. The cluster can have a minimum of 3 devices in a production environment, and you can scale out if you need more. That cluster provides essentially the single point of management for anything and everything you configure on the fabric, whether it is about operations, whether you're configuring the logging type that you want, NTP, or whether you're performing complicated network virtualization configurations. Everything's exposed through a single REST API for all possible configurations and operations of the fabric. And the fabric provides essentially a non-blocking 10-25 gig access with 40 or 100 gig uplinks, so there's no bottlenecks for any type of workloads that you connect, north, south, or east, west, and I'll talk more about that. Now, you can deploy the fabric on a single location, or you can have multiple pods, where you can have pods that are at different locations and have IP connectivity between them and still operate them under a single controller cluster in what we call a multi-pod design. So you can have no longer the need to worry about extension of broadcast domains or extensions of distributed default gateways or distributed services. Now, we have a concept of tenancy, multi-tenancy. What you see on the left is a screenshot, a partial screenshot of the APIC GUI, where you see the tenant folder and all the objects that it contains. A tenant essentially is a logical or administrative boundary that allows you to slice the fabric for multiple users. And under that tenant, you'll have abstracted networking and policy and application definitions. Now, the first definition you need to have is a routing domain or an IP namespace. That's what a VRF is. A tenant can have one or more, and this will allow you to have distributed routing across the fabric. Then we have the concept of bridge domains. Each tenant may have one or more bridge domains under a single routing domain. A bridge domain is essentially a broadcast domain that is effectively implemented in the fabric as a VXLAN segment. The fabric is essentially a VXLAN fabric. Now you can have one or more subnets associated with this broadcast domain, and you can share it across multiple applications as well. APIC will not provision, you do not have to configure any of these on any boxes, right? Compared to, for instance, deploying VXLAN fabric using BGP VPN, which is perfectly possible and supported in the Nexus 9000 family. Here you do not have to configure VRFs, bridge domains, or anything on any of the boxes. The APIC will take care of provisioning those configurations anywhere you need them when they need them. And this allows you to have layer 2 domains that extend as far as wide as you need on the fabric across one or multiple pods, therefore one or multiple locations. The next thing is the L3 out concept. This is an abstraction of the external configurations, the external physical interfaces that connect your physical fabric to any router that provides routing for your data center. This could be Cisco routers, this could be Juniper routers, this could be Alcatel-Lucent routers, any other router. This we're going to abstract so that it's easy to consume them once we define policy, a concept that I'll explain in a minute. How do we attach endpoints to consume these networking constructs? We attach them by grouping them in what we call endpoint groups, or EPGs. This will be a group of devices that will share common policy requirements. This could be all the endpoints in a segment. Therefore, an EPG can represent a VLAN in a traditional networking. Or it could be all the VMs that are attached to a port group, and therefore an EPG could be a port group. Or it could be something more sophisticated, like you're selecting the endpoints based on the operating system, like all Ubuntu machines. Or you could select them based on networking attributes that you could select based on the IP address or the MAC address, or a combination where you can actually say all the vSAN VM kernel links, VM kernel interfaces will be on that particular EPG. If we look at constructs that are more static in nature, we're talking about EPGs. If we're looking at classifying endpoints in a more granular way using the endpoint attributes, we're talking about micro EPGs. You can have as many as both as you want, you can combine them, and for all purposes and means, they're equivalent. The only difference is, again, how do you select which endpoints participate? And in micro EPGs, you do it by using the endpoint attributes, which could be virtual machine attributes, or could be IP or MAC address sets. These EPGs will be associated to bridge domains. That's how you link together the endpoints to the VXLANs and the subnets that can participate in which of one of those VXLANs. In the example, you see two bare metals that are on EPG2 and a number of virtual machines that are on EPG1, all in the same subnet, yet isolated from one another. Of course, you can also have multiple EPGs on the same VXLAN, on the same bridge domain. And you can have multiple bridge domain and subnets as well. In this case, for instance, we have a green VXLAN and an orange VXLAN, and we have on the green VXLAN an EPG that has both virtual machines and bare metal endpoints. The virtual machines may be connecting through VXLAN, whereas the bare metal endpoints may be connecting through VLANs. All of these combinations are possible in the fabric and have no performance penalty whatsoever. The fabric will automatically provide distributed default gateway and distributed routing and policing for all connectivity between and within bridge domains. So you have automatically distributed layer 2 and distributed layer 3 across one pod or multiple pods, so for one site or multiple sites. And all the traffic, whether it is north-south or east-west, and whether it is between physical and virtual, bare metal and external, it's going to go hardware switched, low latency, no bottlenecks on any of these paths. The next point is, how do you enable policy? And we enable policy by defining contracts between endpoint groups. A contract is essentially a set of policy definition, which includes, as you can see on the slide, filters that provide L2 to L4 parameters, the filters that are common in firewall rules or in ACLs, which can have optional logging and copy services. You can define, for instance, that certain filters will redirect copies of the packet to a copy device. So the filters define what security you allow between endpoints. You can also put QoS settings, and you can also put service graph settings, which I'll explain later and serve to augment the security policy with more advanced devices. Now, we implement a complete whitelist policy model, which means that if you have groups defined on the same subnet or different subnet, without any contract between them, they can simply not communicate. In that sense, the fabric is like a giant firewall of sorts. Now, this is the default. This default can be turned off on a per VRF basis. So you can define a VRF where you have no policy enforcement, and you can change that at any moment that you see fit. When you define a contract, you enable connectivity. For instance, here we have a contract between the green and blue EPG that enables the green EPG to listen on ports 80 and 443. So now the blue EPG or the endpoints on that EPG can open connections to those ports, such as in the green arrow. If they try to open connections to ports that are not part of the contract, those connections will be dropped in hardware and logged. Similarly, in this case, if the green EPG tries to open connections to other ports on the blue EPG or even to the same ports on the filter, those connections will be dropped as well, because the contracts can be unidirectional or bidirectional. It depends on who provides and or consumes the contract. So this allows you to define very fine-grained L2-4 policies for any type of connectivity between external endpoints and EPGs or between EPGs. Then there's the concept of application profile. And an application profile is essentially a folder in the APIC or an object that groups a number of EPGs and the relationships that are pertaining to a particular application. So this means EPGs that should be working together and have contract relationships between one another. Now, those EPGs on one application profile can have contract relationships with EPGs in other application profiles as well. There's plenty of flexibility here because many applications will have to talk to other applications as well. So the application profile is more like a logical grouping that makes sense for your administrative purposes. Finally, insertion of services like next generation firewall or IPS-IDS systems or load balancers is done by augmenting the contract through a service graph. Picking on the same example as before, if we now want to add a load balancer and a next generation firewall in between them, we would attach a service graph that concatenates those two functions to the same contract that we were using before. And that will enable the fabric to redirect the traffic to the relevant appliances, which could be in this case an ASA appliance and a big AP appliance. This could be physical or virtual appliances, and the AP will perform the configuration on those devices to stitch them to the fabric and to provide the connectivity or the configuration required for the service that you're provisioned between those EPGs. This will be clearer in the demo. Now, moving into the demo, I've decided to do a relatively sophisticated demo of these capabilities. I'm going to start with a really simple application. It's a two-tier application where you have a Joomla frontend with a SQL database. Joomla is an open source content management system similar to WordPress. Now we're going to front-end this with a load balancer that it will implement a public IP address, 172.16.1.100, that's going to be filtered by an ASA firewall that provides connectivity to the external world. We're going to have a couple of virtual machines in the production EPG for web, serving that particular web page, and we'll be pulling the content from a database, which will be running on the same subnet of the virtual machines that implement the Apache servers. And we have a transparent firewall also added in between the database and the web server. Now, this is not necessarily to represent how you should do things at all. It's just to illustrate the possibilities. Now, let's say that's our production environment, and we'll review that environment and how it's working. But then we will also create another environment for developers that want to modify this application. And these will have essentially a base EPG and a port group where we will have a new server on Joomla app servers and a copy of, which is a complete clone of the production database, down to using the same IP addresses and same IP address space. While we're provisioning, our server will only have access to Ansible for provisioning purposes. Once we have provisioned the new virtual machine, without vMotion it, we will simply change attributes of that virtual machine to indicate that it's now ready for the development environment and our developers to work with. We will also allow our developers to launch virtual desktops so that they can actually test the application as they're changing it. Once they're happy with the changes, they can create a test environment and attach it to the firewall. On that test environment, we'll be using a different load balancer. We've chose to use an open source load balancer, let's say proxy. Again, when the application change has been ready, you just change VM attributes to change the classification of the VM into the web EPG for testing. That will automatically change the configuration of the HA proxy and open up the ports on the firewall so you can test your application from an external source. And when you're happy with your test, you can again change VM attributes that indicate that that virtual machine is now for production. The virtual machine will never change port group. You might vMotion it into another cluster if you want for production workloads. But the only thing you need to do is change an attribute for that to join the production micro EPG. and automatically the APIC will update the firewall and load balancer configurations. Finally, we can also decommission the older version of the application, and again, the APIC will take care of deprovisioning the firewall and the load balancer configurations. So let's move to the demo. Here we're seeing, and we're going to be switching back and forth between the APIC vCenter plugin and the APIC graphical user interface that the Fabric administrator will typically use, if not using the REST API or some orchestrator. In this case, for instance, we're looking at the canvas view of the application where we see the external connectivity. Again, this is an abstraction of the connectivity to an L3R interface, to a real firewall. In this case, we've defined one that provides a default. So all the traffic that comes in and out can go through that connection. And that enables traffic to internal EPGs, those are the blue bubbles, according to the contracts that are represented by the by the green bubbles. So now, if we look and explore here, we can see by hovering that we're providing access to from a default, and we're providing access for ICMP and a web filter that will send the traffic through a Cisco ASA and an F5 load balancer. By hovering over the micro EPG, we can see the endpoints that are connected on that EPG, and we can see that those endpoints now have access to the database. Let's keep track of the IP addresses. The subnet is 172.16. .10.200 is the database, .12 and .14 are the production web virtual machines. Only SQL and ICMP is allowed between only those servers on the micro EPG for web and the database, and that traffic has to go through a transparent firewall and ASA. Now let's look at this from a vCenter perspective. Oh, let's first launch, this is our text desktop. So this is a desktop that is external to the Fabric. And from here, we're just running constantly this simple bash script that is just downloading the web page for our website. And this is running on the background just to generate some sessions and some traffic. So essentially, we're hitting the load balancer. The load balancer is sending to both virtual machines in production, which is fetching from the database. This is the view on the Big IP dashboard where we see those connections coming in. And this is the current configuration where we see on the F5, we have a virtual IP address, and we have the two members, the .12 and .14 IP addresses on the micro EPG. This has been configured by the APIC and will be constantly configured and updated by the APIC, as we will see in a minute. This is the ASA, where we can see in the logging the connections that are happening between .12 and .14 towards the database, the .200. So these are, as we hit the load balancer will go to one or the other server, and they will fetch the connections from the database. And if we look at our website, we can actually see a default web page where we can see that we first hit server 1 and then server 2. We just added that watermark to the website so that we can see which one we're hitting. Now we have our unprovisioned virtual machines on our Joomla app server VMs. Here we have, for instance, .15. Again, we're always working with the same subnet, very simple, flat design. And what we're going to do here is, we're going to imagine that we have used Ansible already. We've provisioned Joomla, we've provisioned everything we need, and we're ready to move that virtual machine into the development environment. So here we're on the APIC where we're looking at the development web micro EPG, Joomla Web Dev. There are no endpoints connected to it. Now in this demo, I'm going to change the attribute, the name of the virtual machine, to select where I'm going to place the virtual machine. Now on a typical environment, you wouldn't be overloading the name for this. You would use some sort of other attributes, like custom attributes or otherwise. So here, for instance, we can see that all virtual machines involved in this demo are on the same port group. They're never going to leave the same port group. And what we're going to do is we're going to change the server 3, and we're going to add it to the web dev environment. Again, this is something that you would do just by changing an attribute other than the name. This is just for simplicity when running the demo. As soon as we do that, the virtual machine was reclassified, and within the same port group, but we reclassified on a different group, on a different micro EPG. Micro EPG in that sense is going to be similar to a security group if you want. So now we can also, and we could have seen this directly as well here. Now we go to the development micro EPG, and we see the .15 IP address appearing there connected. Now, different policy applies to this virtual machine. This virtual machine was previously restricted to working only towards the Ansible server. It was completely sandboxed and isolated. It could only be provisioned using Ansible. Now, it has access to the development environment. So again, it's still sandboxed. It cannot connect to the production database. It cannot connect to anything outside of its sandboxed environment. Across this demo, you will see that I run mmap at various points just to do a port scan between the virtual machines and the subnets so that you can see that the contracts are actually very effectively filtering and you can only see what you absolutely need. In this case, we can now ping the database. The database is in another micro EPG for development, but we can only see one port open, 3306, on that database. As we do a port scan, and we can see that later, if I recall correctly, we're generating logs for all the ports that we're dropping, right? We're port scanning and we're generating logs. Now, what we're gonna do now is we're gonna augment that contract. So you can do that easily from the vCenter plugin. Here we're augmenting that contract to add SSH. And maybe we wanna conduct some additional tests for performance, so we're gonna add iPerf as well. So we're essentially very simply open up new ports, new services directly from vCenter between those virtual machines. Regardless of where they are in the topology, they could be on the same pod, they could be on different pods and therefore different data centers. So now if we conduct the same port scan, we will see the additional ports that have been opened. And that's what we're gonna do. We can now see that we'll be seeing port TCP22 and 5001, the default port for iPerf. This is just to prove you or show you that these contracts are effectively very simple and easy to configure from a vSphere admin perspective if your Fabric administrator wants to delegate that possibility for you. So now our developer is changing just a banner, right? They're changing an image on that device, and they're going to perform the test. They can launch a virtual desktop to perform that test. And we're going to see that we're just making a very silly, simplistic change. We're just adding the logo that powers everything, the APIC logo, to our default web page. So now our developer can move this into the test environment. And again, we're not going to have to do any complex provisioning. An orchestrator or a continuous integration workflow could just leverage changing attributes using the vSphere APIs to signal that it wants to move the endpoint from one stage to the next. So if we go now, again on the APIC, we're going to go to the testing micro EPG, so the web test micro EPG. At the moment, we see the HA proxy has one leg connected. And what we're going to do is we're going to again change the name of the virtual machine. And as soon as we do it, we are moving away from the development micro EPG into the test micro EPG. Again, different sets of policies apply. Now we're not so sandboxed. Now we have a HA proxy front-ending us. Now we have a firewall that allows that HA proxy load balancer to be accessible from external devices. So if we go to HA proxy and we look at the statistics page, we see that the web server 3 now appears, is available. And we will be able to connect to that HA proxy virtual IP address from an external device because our contract allows us that. Again, if we highlight here the testing environment, we can see that it does have access to the external L3 out interface. And again, providing access to external devices is as simple as creating a contract with or without a firewall with the filters that you want to that L3 out. You don't have to deploy gateways, you don't have to configure routing or anything like that. That's something that the Fabric administrator does for you when the routing is configured, and then you just consume this as much as you need. So in our case, we're going to be able to access the .200 IP address from external devices. Now we can test from an external user. So if we go back to our external desktop, we still can access the production web server, but which is on the .200 address, .100 address. We will also be able to access the 200 now, which is where we have our test environment. We're going to see whether that is working. The test environment should be able to reach the database, and that's actually what it takes a little bit because we've changed the Joomla to actually sync from another database. But once it's done, it now fetches from the server 03 And we can see that the test is successful. So we're going to repeat the same operation. And this is a bit boring to see the same thing, but it's going to get interesting because now we have a lot more things to update. We're going to move into production. As we move into production, we now need to update more things. So we'll update the F5 and we'll update the firewall. So once again, now we have 3 servers in production. Because we're in the production environment, we're much more restricted, right? We no longer are allowed to ping the database. We're no longer allowed to do a bunch of things. Again, if we were to conduct an Nmap, we will see that we're completely isolated. We cannot even ping our neighbors, right? This is an isolated EPG. Here I'm trying to ping the other servers on the environment. I cannot, right? This is completely restrictive. I'm gonna just speed up this a little bit. So we see that only the database is open on the right port. Now if we refresh the map on the F5, we see that automatically the IP address has been added. Nobody had to do anything for that. The pool on the F5 is configured to monitor the EPG, and whenever an endpoint comes or goes, it will automatically update it. Similarly, on the ASA configuration, we see that the object that allows access to the database has been updated with the .15 IP address. So as soon as we move that virtual machine, not move, but change, reclassify into the production micro EPG, the APIC took care of updating the F5 configuration and the firewall configuration. This is something that we can do for other manufacturers as well, not only for F5 and Cisco firewalls. You can actually do this for Palo Alto, Checkpoint, Fortinet, Citrix, Netscalers, and so on. So now we can actually test the application on the production IP address, and we'll hit different servers. Now what happens here is we open multiple sockets and we fetch one banner from one server and one banner and one part of the page from the other server. So we can see that the banner is there, but we're hitting server 2 for other parts. What happens here is we need to decommission the servers that don't have the right version of the application. So simply again, we just change the attribute. By removing the right attribute, those servers will be removed from the micro EPG for production. They will be put back in the base EPG where we can reprovision them, so they're sandboxed again. Here they are on an EPG where they only have access to the Ansible provisioning system or whatever provisioning system you decide to use. And now all the connections are flowing through the .15 IP address. So we've effectively transitioned to the new production system. Now all we have to do is clone that virtual machine, create as many copies as we need. The API will take care of updating again the firewall and the load balancer for the new virtual machine's IP addresses as they come forward. And effectively, we have done the cleanup as well. As those virtual machines have been moved away from production, we've cleaned up the rules on the firewall and on the F5 load balancer, which we're going to check in a minute. So here we can refresh the firewall configuration. We look at the configuration, this is still the 3 IP addresses. As we refresh it, .12 and .14 disappear, and we see only .15. And similarly for the F5. So in a nutshell, and if we wrap it up, you can use the APIC as your domain manager for automating any task, whether it's for virtual or physical networks. The example that I showed before was pure virtual machines, but you can actually perform the same communications with a physical database. You can automate using the API. It's a very well-documented, easy-to-consume Northbound API, completely open, unlicensed. But we also provide native integration with the key cloud management and orchestration systems, including OpenStack, supporting multiple distributions, vRealize automation with a plugin for VRO, Cisco, obviously, with Cisco Cloud Center or UCS Director, Microsoft Azure, as well as integration with Docker, including Kubernetes, Docker Swarm, and other frameworks. So with that, I conclude the presentation. I hope it was useful, and thank you very much for your attention.